Hello everyone, welcome back to this online class. Today we are going to look at how to find Fourier transform of a function. In particular, we are given the function f of x is equals to exponential negative absolute value of x. And the domain is from negative infinity to positive infinity. Remember, Fourier transform is extending. When you are getting the Fourier transform of function, the independent variable must extend from negative infinity to positive infinity, the complete domain, from negative infinity to positive infinity. Solution. So, first of all, we need to know how to split the given function. So, split the absolute value function Remember from calculus how you are splitting absolute value functions that, when you talk of absolute of x, is simply the same as it is negative x or positive x. When is it negative? If x is less than 0. And this is if x is greater or equal to 0. For simply positive, you see it is 0 if x is equals to 0. And it is positive if x is greater than 0. So that's the absolute value of x. Therefore, we have negative of that absolute value. This will now be this function. It will be positive x or negative x if x is less than 0, if x is greater or equal to 0. So therefore, what about the exponential? See, when we say x less than 0, is this interval is the same as negative infinity less than x less than 0. This is the same as 0 less or equal to x less than positive infinity. So therefore, our f of x, which is simply the exponential of negative of absolute of x, can now be written as, it will be exponential x or exponential negative x. It is exponential x if 0, oh, not 0, we start from negative infinity. If negative infinity is less than x less than 0, this side it is from 0 less or equal to x less than positive infinity. So that you see, this is a piecewise function. Piecewise function. We talked about piecewise function as a function that has several branches, more than one branch. So this is a piecewise function. Why are we calling it piecewise? It has more than one branch. Any function that is having two or more branches is called a piecewise function. Now, how do we find the transform of that function? Remember from the definition of Fourier transform, if we say let f be the Fourier transform operator in the variable x, because it is x that extends from negative infinity to positive infinity. So now the Fourier transform of f of x, Fourier transform by the definition, of Fourier transform is always the integral from negative infinity to positive infinity exponential negative iota omega x times f of x dx. And you see this interval can be partitioned into two. You see we are starting from negative infinity to 0. Another partition is from 0 to positive infinity. So we partition our interval into two parts. The first part is from negative infinity to 0 exponential negative iota omega x f of x dx. The other partition is from 0 to infinity exponential negative iota omega x and then f of x dx. So you need to ask yourself, what is the value of f of x in each of those partitions? Like here, in the first partition, our f of x is exponential x. Look at that. In the other partition, our f of x is exponential negative x. This one here. So now this can now be written as, and you see you can use the laws of indices to combine those two exponential functions so that we'll have the integral from negative infinity to 0 exponential negative I omega x plus x. I have combined this and this one. So you add the powers. Here we have dx plus the other one is integral from 0 to infinity exponential negative I omega x minus x dx. And you can as well write this as the integral from negative infinity to 0. I can see x is common, so we'll have 1 minus I omega x dx. The other one is from 0 to infinity. Negative x is common, so we'll have negative of 1 plus I omega x dx. And now you can use substitution to evaluate those integrals. I know use substitution is easy. When you integrate these ones, you need to get, in the first one, you need to get, remember we are integrating, so we are going to get 1 over 1 minus I omega times exponential 1 minus I omega x. Remember the limits are from negative infinity to 0. From x is equals to negative infinity to 0 plus the other one. Remember these are improper integrals, so it's better use the pincer method of evaluation, where you introduce limit as a approaches negative infinity, the other one is limit as b approaches positive infinity. They're still the same. The best way is to use pincer method of evaluation. The other one should give us negative 1 over, here now we have 1 plus I omega exponential negative 1 plus I omega x. The limits for this other one is from 0 to infinity. X is equals to 0 to infinity. So let's plug in the limits of integration so that in the first one, we'll have 1 over 1 minus iota omega. When I substitute 0 where there is x, I'm going to get exponential 0, which is 1, minus, when you substitute in negative infinity where there is x, you get exponential negative infinity. You see exponential negative infinity, you can write a note. that exponential negative infinity is the same as 1 over e raised to infinity. And the result is 0. So I'll have a 0 here. Then plus. But I can see there's a minus, so I'll just have a minus. Minus 1 over 1 plus I omega. Now here, look at the exponential function. If you put x to be infinity, again it will be exponential negative infinity, which is 0. Then minus, when x is 0, it will be e raised to 0, which is 1. So this is the same as 1 over 1 minus I omega plus 1 over 1 plus I omega. If you get the LCM, the LCM is 1 minus I omega times 1 plus iota omega. So 1 minus I omega will go there. How many times? That will be 1 plus I omega times 1, which is the same. Then plus 1 minus I omega. So what do we realize is that the I omega will cancel with this, so that we have 1 plus 1 is 2. Here we have 1 minus I omega times 1 plus I omega. And you see in the denominator is a difference of 2 squares. So just like a plus b times a minus b. That is a squared minus b squared. So this is the same as 2 over a squared is 1 minus b squared is I squared times omega squared. But I squared is negative 1. So therefore our answer here, therefore that Fourier transform of f of x should now give us 2 over 1 plus omega squared. So you see Fourier transform will transform the x variable or any variable that extends from negative infinity to positive infinity to a new variable, which is omega. So what our results that we have there is a function of omega. That is our Fourier transform. So thank you all for watching this video. Please subscribe to my YouTube channel, that is Professor Francis Okech. If you go to the YouTube search, type Francis Okech or Prof Francis Okech, and you will find me right there. Also, don't forget to comment, like, and share this video. When we meet next time, we'll look at other problems in Fourier transform. Bye-bye.